Using the discriminant. In this video, we will classify quadratic equations by number and type of solutions using the discriminant of the quadratic formula. Let's review the quadratic formula. And this is used to find the solutions for a quadratic equation in standard form. And the formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Recall that quadratic equations can have two solutions or roots, one solution or no solutions. And let's zero in on the expression underneath the radical, the b squared minus 4ac. We call that the discriminant. The discriminant will help us classify quadratic equations by their roots. And if you just think mathematically for a moment about taking the square root of something, what if there were a negative number underneath the radical? There would be no real solution, right? If b squared minus 4ac were 0, then my root would just be a single root. It would be negative b over 2a, because adding or subtracting 0 won't change the value. And if b squared minus 4ac is positive, if the discriminant is positive, we'll have two roots. Let's think of the graphs of quadratic functions. We're asked to describe the roots. In other words, the number of times the curve crosses the x-axis. There are two real roots in the first graph. And they look like rational roots. They look like numbers that can be written as fractions or integers or non-terminating, non-repeating decimals. Right? So those are rational roots, two of them. In the middle function, there's one real root. There's one place where that curve crosses the x-axis. It looks like x equals 2. But in the third example, there are no real roots. So going back to the discriminant, the top left function, the discriminant would be positive. That lets me know there's going to be two real roots. In the middle function, if I knew the equation in standard form and I substituted it into the quadratic formula, the b squared minus 4ac part would equal 0. And in the final example, b squared minus 4ac would be negative. So now let's consider the equations of quadratics and let's describe their solutions. So I'm not going to graph these with the graphing calculator. Instead, I'm going to identify A, B, and C from the standard form, and then consider just b squared minus 4ac. Remembering when you square b, you're squaring a negative, so you get 16 minus 4 times 1 times 3. 16 minus 12 is 4. That's a positive number. Since b squared minus 4ac is positive, there are two real solutions. In fact, there are two rational solutions. In the second example, a is 1, b is negative 4, and c is 4. The discriminant of the second example will be 0. That tells me that there's one real solution. The vertex of the related quadratic function would be on the x-axis. And in the last example, a is 1, b is negative 4, and c is 5. b squared minus 4ac is actually a negative number. You can't have a negative underneath the radical. So therefore, this one has no real roots. There's no solutions to this equation. No value of x will make that equation true. So a little bit more practice. You can try A, B, and C by putting the video on pause. Use b squared minus 4ac and determine the number of solutions of each quadratic equation. Okay, example A, we end up with a negative discriminant. Therefore, there are no real solutions. In example B, we end up with a positive discriminant. But remember, the discriminant will be underneath the radical sign, and you can't conveniently take the square root of 41. That's going to be an irrational number. Therefore, while there are two real solutions, they're both going to be irrational. They will cross the x-axis somewhere, but not at a place where we can readily identify. In example C, the b squared minus 4ac will be 0. And how we interpret that is we say that there is one real solution to this quadratic equation. The value of x that makes this quadratic equation true happens to be -4, but we were not told to solve this. We were just told to find the number of solutions, which we've done. One real solution, for example, C. Okay, so there are going to be 3 more practice problems for you, which we want you to solve. Show your reasoning and refer back to some of the exemplar problems in the video for help.